The day I was entered into the Kareth Sol Advanced Combat Labyrinth program, clerical officer in the Academy's enrollment division made an error of 2 characters. My designation in the intake system was D4V0R1N, standard Terran encoding. The Academy's software had been updated 3 years prior to accept the human alphanumeric format after Earth's provisional membership in the Conclave of Aligned Worlds. What the officer typed was D4V0R1N, same string, except she used a numeral 0 in the second position instead of the letter O. It routed me to the operational readiness track instead of the observational research track. OR1 instead of OR1, 2 characters, separated by 12 letters of the alphabet, and about 700 vertical percentiles of expected combat aptitude. I found out 3 weeks later, standing in the lower intake hall of Kareth Sol, with 49 alien cadets, who had each passed a preliminary screening so rigorous that 2 of them had apparently been hospitalized during the qualifying round. I was holding a data chip that said Advanced Combat, Labyrinth Certification Program Enrolled Cadet, D4V0R1N, and reading it the way you read a bill for a restaurant you didn't eat at, the intake officer. A Veth Nalari, which is a species that looks something like a 6-foot mantis crossed with a professor of literature, all narrow thorax and precise mandible movement, scanned my chip, looked at me, looked at his scanner, looked at me again and said, "You are the human." "I am," I said. "This program," he said carefully, "the way you speak to someone you think might be unwell, is not the observational research track. I gathered. It is the Advanced Combat Labyrinth program. The chip says." He looked at me for another long moment. His mandibles did a small tight movement that I had learned, in the 5 weeks since my arrival at the Academy, meant something between professional uncertainty and private alarm. The Labyrinth has a recorded failure rate across all enrolled species of 63% in the first attempt, he said. The median completion time for successful cadets is 2 hours and 17 minutes. The trial period is 40 minutes. I waited for him to continue. Cadets who do not complete within 40 minutes receive a conditional hold. They are permitted to re-enter for a second attempt after a rest interval. There is no shame attached to the conditional hold. It is the expected outcome for most first-attempt cadets. "Okay," I said. He looked at me once more with his careful, precise literature professor eyes. "You understand I am telling you this because no human has been enrolled in this program before." I figured. "And you wish to proceed." I looked at the chip. I looked at the room full of alien cadets who were to varying degrees pretending they weren't watching me. I thought about the clerical officer somewhere in the enrollment division who had pressed the wrong key. I thought about the 8-hour transit I'd taken to get here, and the administrative filing I'd have to complete to transfer back to the observational research track, which would take approximately 11 days, during which I would have no program assignment and therefore no housing allocation. "Yeah," I said, "I'll proceed." The intake hall was a long, low room with benches arranged in 4 rows, and I took a seat in the 3rd row because the second was full and the 4th was in a draft. Cadets around me were a cross-section of species I recognized and several I didn't. To my left sat a Darathi, roughly humanoid, gray-skinned, dense in the shoulders, with a secondary rib cage visible through a mesh training suit that suggested they had more structural redundancy than seemed fair. To my right, a Velshen cadet, one of the long-limbed species from the outer reach, iridescent, scaling along the neck and forearms, and the kind of resting expression that, on a human face, would have signaled mild contempt, but on a Velshen meant nothing in particular. I had been at the Academy for 5 weeks. I had come on an observational research exchange, which was exactly what it sounded like. Program that embedded human scholars in alien institutions to document social and academic structures. I had a background in acoustic engineering. Particular research focus was institutional architecture, how alien buildings used spatial design to manage population flow and environmental conditions. I had chosen the Kareth Sol Academy because its main campus had been built 800 years ago by a now extinct species called the Aerith, and the Aerith were famous in very specialized academic circles for a building philosophy that used acoustic resonance as a primary structural logic. Their buildings were not just designed to be walked through, they were designed to be heard. Every corridor, every chamber, every junction. The dimensions were calculated to produce specific resonance effects. The Aerith believed you could understand a building by listening to it. I had spent 5 weeks walking the Academy's halls with my mouth half open and my recording equipment in my bag, doing exactly that. The intake officer stepped to the front of the room, and the cadets settled. The ambient noise level dropped in the way it does when a group of beings simultaneously decide to attend to something. A frequency shift more than a volume drop, the particular silence of held attention. Welcome to the 41st cohort of the Kareth Sol Advanced Combat Labyrinth program, the officer said. His name I had seen on his desk placard was Instructor Velharith, though he had not introduced himself. You have been admitted to this program because your preliminary screening results placed you in the upper 4 percentile of combat readiness scores, your respective species and age cohort. You are, statistically, the finest cadets currently enrolled at this academy. He paused there in a way that I recognized as deliberate, the kind of pause that says, absorb this, because the next line is going to revise it. The Labyrinth will not care, he said. He let that sit for a moment. The Kareth Sol Combat Labyrinth is a closed environment of 42 chambers, connected by 118 corridors. It was designed by the Academy's founders 760 years ago and has been in continuous operation for certification training since that time. In those 760 years, it has never been completed in under 18 minutes by any enrolled cadet. He let that sit too. He was good at pauses. The chambers are equipped with environmental disorientation arrays, gravitational variance, atmospheric pressure fluctuation, sub-frequency acoustic emitters, and spatial recalibration panels that alter the apparent geometry of each chamber upon entry. The purpose of these systems is to test cognitive function under compound sensory stress. Your ability to navigate, reason, and move under conditions that attack your sensory processing is the specific competency this program certifies. A cadet in the first row, a Dorothi, bigger than the one next to me, with the secondary ribcage pushed out in what I'd come to read as species. Default confident posture, raised a hand. Instructor. What is the disorientation array calibration protocol for this cohort? Standard, elevated, extreme. Velharith looked at the cadet. Standard for chambers 1 through 12. Elevated from chamber 13 onward. The big Dorothi settled back. There was a murmur in the room that I didn't have enough context to read. You will each be assigned a marker chip at the checkpoint station. The chip logs your position in real time and transmits to the oversight station. You carry it throughout the trial. When you reach the terminal chamber and press the chip to the exit sensor, your time is recorded. You may exit through either the terminal sensor or, in the case of a conditional hold, through the emergency withdrawal protocol at any chamber. He looked around the room. His mandibles moved in that careful way again. The trial begins in 40 minutes. Use the remaining time for preparation. Water and nutrient supplements are available at the far station. If you have questions about the emergency withdrawal protocol, ask now. Nobody asked. I don't know if that was courage or species-wide stubbornness or the statistical self-selection of the top 4%. Probably some combination. Velharith started to spack from the front of the room, then paused, an unscripted pause this time, tell the difference, and looked in my direction, not at me directly, in my direction. One additional note, he said. The disorientation arrays are calibrated to the known sensory profiles of registered conclave member species. Human sensory parameters are on file from the Terran Integration Protocol dataset. He paused once more. This cohort includes, first time in the program's history, a human cadet. The arrays are calibrated accordingly. I felt the attention in the room shift to me the way air shifts in a space when someone opens a door at the far end. Not sudden, not dramatic. A pressure change. I was looking at the data chip in my hands. I turned it over once, put it in my pocket. The big Dorothi in the first row turned around and looked at me. His expression was not hostile. It was the expression of someone doing a rapid calculation and arriving at an answer they found mildly interesting. He turned back to the front without saying anything. The Velshen cadet on my right had gone very still in the particular way Velshen go still when processing something. After a moment, without looking at me, they said, in the low-register conclave standard that carries at conversational volume. Have you ever completed a sensory disorientation course before? Not formally, I said. They absorbed this. The sub-frequency arrays produce resonance effects in the 18 to 40 Hz range, they said. Vel Shen, the primary effect is spatial disorientation. The perceived dimensions of a chamber become unreliable. Balance degrades. Spatial memory becomes untrustworthy. What's the effect on humans, I asked. Though I already had a rough sense. File says approximately equivalent to Vel Shen response. Spatial processing degradation, balance impairment, mild proprioceptive disruption. The file, I said. The Terran Integration Protocol dataset, they said. Yes, I nodded. Shh. The Vel Shen cadet looked at me then. A full turn of their long-necked head, the scaling catching the overhead light. Are you concerned? They asked. Not unkindly. The question was genuinely curious. Not particularly, I said. They looked at me for another moment. Then they turned back to the front. Here is the thing about the Terran Integration Protocol dataset. It was assembled 11 years ago, during the first round of Conclave Earth contact, by a joint commission that spent 14 months compiling everything the Conclave knew, or had observed, about human physiology and sensory function. It was thorough, well-intentioned, and based primarily on medical records, laboratory assessments, and a series of controlled sensory exposure trials conducted at a Conclave research station, with a sample population of 47 volunteer humans, most of whom were physicians, scientists, and 2 professional athletes. The dataset knew what infrasound does to the human vestibular system in a controlled laboratory environment. It knew the measured degradation curves for human spatial processing under sub-18 Hz stimulation. It knew the standard human response to gravitational variance up to 1.4 standard and atmospheric pressure fluctuation in the -15 to +20% band. What it did not know, because this is not the kind of thing that gets captured in a laboratory with 47 volunteers, was what a decade of working inside heavy industrial port machinery does to your relationship with infrasound. I grew up in Callaway Bay, is a commercial port city on the southern coast of the continent that used to be called North America. Callaway Bay is, depending on how you count it, either the 3rd or 4th largest shipping port on Earth, and it operates on a cycle that never fully stops. Port machinery, the deep crane rigs, the pressure wash systems, the submarine freight loaders, the channel dredging equipment. All of it runs at frequencies that range from subsonic to barely audible, and all of it vibrates through the concrete, the water, the air, and eventually the bones of every person who lives in a 5-kilometer radius of the waterfront. My father was a marine acoustic engineer. His specialty was the resonance profiling of underwater structures, docks, pylons, channel walls, to assess structural integrity without physical inspection. You map the way sound moves through a structure, and the structure tells you what's wrong with it. I helped him with fieldwork from the time I was 8 years old. Not because it was required, because he let me come along and I found it interesting. By the time I was 12, I could identify a failing dock pylon by the change in its resonance signatures, the way other people identify a burning smell in a kitchen. By the time I was 15, I could walk into a room and tell you within 3 meters where a concealed machine cavity was located based on the way the room's ambient sound folded around it. By the time I finished my engineering degree, I had spent so many hours in the sub-frequency fields of industrial machinery that my vestibular system had, as my dissertation advisor once put it in a faculty meeting, compensated to the point of apparent immunity. She was not entirely right about that. Infrasound still does things to me. The spatial processing effects the Vel Shen cadet described, I feel those. Sieve geometry of a room gets soft around the edges. Distances telescope a little. It's real. But I learned to navigate in that condition when I was 9 years old, standing next to a running channel dredge at 2 in the morning while my father mapped its resonance against his clipboard. The Terran Integration Protocol dataset knew what infrasound does to the average human. I am not the average human. I don't say that with pride. I say it the way you say the car you grew up with had a quirk with the heater. It's just accurate. They assigned us our marker chips at the checkpoint station 30 minutes before the trial began. Mine was a flat disc about the size of a large coin, warm to the touch, with a dull green indicator light that told me it was active and transmitting. Clipped to the shoulder of my training suit. The training suit, I should note, was issued by the Academy and fit poorly. It was designed for Shen body proportions, which run long in the torso and narrow in the shoulder, and I am not that. I'd had 5 weeks to get used to it. You manage. The cadets around me were doing pre-to-trial preparations of different kinds. The big Dorothy in the first row was running a series of slow joint mobility sequences, methodical and precise. Several of the Shen cadets were doing something with their breathing. A controlled rhythm, 4-count inhale, 6-count exhale, that I recognized as a pressure equilibration technique. A few others were reviewing data pads, last-minute spatial mapping of whatever publicly available information existed about the Labyrinth's layout. I was sitting on the bench with my eyes half closed, doing nothing that looked like preparation. What I was actually doing was listening. The Academy's main building is Aerith original construction. The enrollment hall, the administrative block, the primary lecture theaters, all Aerith, 800 years old, built on the acoustic resonance logic that I'd come here to study. But the Labyrinth facility, attached to the north face of the main building by a corridor, added 200 years ago in a renovation, was not Aerith built. It was conclave standard construction, efficient, functional, acoustically flat by design. Acoustically flat by design does not mean silent. It means the acoustic properties are predictable, consistent, minimally reflective, which, to someone who knows how to read acoustic spaces, means highly legible. I had been listening to the Labyrinth building for 35 minutes. Not to the Labyrinth itself. I couldn't hear inside it from here. The shielding was too good. But to the structure around it. Resonance patterns of the outer ensembles, the ventilation geometry, the way the building's footprint absorbed and returned ambient sound. You can map a building by listening to the outside of it, if you know what you're listening for. It's not precise. It won't give you a corridor-by-corridor schematic. But it gives you a general sense of volume distribution, where the large chambers are relative to the small ones, where the major structural voids sit, how the internal mass is arranged. It's like reading a very blurry photograph. The Labyrinth was roughly symmetric, front to back. The large chambers, the ones with the volume that a 42-chamber space would need to reduce its mapped completion times, were not distributed evenly. There was a concentration of volume in the central section, and a second concentration near what I estimated to be the far third of the structure. The entry section, the section I'd be walking into, tighter, smaller chambers, or more of them, or both. I opened my eyes, I checked the indicator light on my marker chip. Still green. The Shen cadet next to me was on their 4th cycle of the breathing exercise. Without pausing it, they slid their eyes sideways at me. You should prepare, they said, muffled by the breath count. I am, I said. They said nothing more. Harith called the cohort to the entry gate at 20 minutes past the hour. The entry gate was not dramatic. It was a standard sliding panel, the kind you find on every internal division in conclave construction buildings, set into a wall of matte gray composite. Above it, a sensor housing. Beside it, the proctor station, which was occupied by the program's oversight AI. A voice-only system, no physical housing, just a speaker grill, and a sensor array mounted at eye level, and a junior officer who appeared to be there primarily to ensure the AI's physical infrastructure didn't malfunction. Harith stood to one side of the gate. He was looking at us the way you look at a collection of objects you have spent your career studying. Appraising, not hostile. Trial is individual, he said. You will enter in the order your numbers are called. There is a 90-second gap between each entry to prevent spatial interaction inside the Labyrinth. When you enter, the first chamber's arrays will engage at standard calibration. You will feel the effects begin approximately 4 seconds after the door behind you seals. He looked down the row of us. The 40-minute threshold is the pass mark for first attempt. If you complete before 40 minutes, you receive full certification. If you complete between 40 and 60 minutes, you receive partial certification and are eligible for recertification in the next cohort cycle. Beyond 60 minutes, Proctor AI initiates emergency withdrawal. He paused. Your chip number sequence is randomized. The Proctor AI will call names. The speaker grill buzzed softly, and the AI's voice came through, neutral. Neither mechanical, nor particularly warm, just clear. It called a Dorothy name first. The big cadet from the front row stood, checked his chip, and walked to the gate. Velharith did not look at him as he passed. The gate slid open, closed. They called them in groups with the 90-second gap, and I stood in line and listened to the building. Not trying to extract more data. I had what I had. I was just listening because it settled me. The way some people settle with their eyes closed, and some people settle by moving their hands. My name came 8th, or the number did. D4V0R1N. Was already standing. I walked to the gate. The junior officer scanned my chip. The indicator was still green. Velharith was looking at me. Not the way he'd looked at me before, in the intake hall, with a professional caution of a man managing a procedural anomaly. He was looking at me the way you look at something you're genuinely uncertain about. Not threatening and not reassuring. Just uncertain, he said. 40 minutes, cadet. I know, I said. The gate opened. The first chamber was larger than I'd expected. That's the thing about mapping a building by sound from the outside. You get volume distribution, not geometry. First chamber had the compressed volume I'd registered for the entry sections. But it was compressed vertically, not laterally. It was wide and low-ceilinged, roughly rectangular, with 4 corridors exiting from the far wall and 1 on each lateral wall. 6 exits total, not counting the entry gate behind me. The gate sealed. 4 seconds, Velharith had said. I counted them. On the 4th second, the arrays came on. I felt the sub-frequency field before I heard it. Or more precisely, I felt it the way you feel bass through a floor rather than hearing it through air. A pressure change low in the sternum, then the spatial effect. The room's geometry softened. The far wall, which had been clearly 30 meters away, became difficult to fix at a precise distance. Somewhere between 25 and 40, my eyes said, and they were both correct and useless. I stopped relying on my eyes. The thing about spatial disorientation in a subfrequency field, the Terran Integration Protocol data set measured correctly, is that it attacks the brain's interpretation of visual spatial data. The eyes send accurate information. The brain's processing of that information becomes unreliable. Distances estimated visually are corrupted. Depth becomes uncertain. The sense of the room scale loosens. But sound doesn't work that way. Sound is not processed through the same spatial interpretation system. Acoustic spatial reasoning, the ability to locate yourself in a space by its flexions, its resonance, its echo profile, runs through different neural pathways than visual spatial reasoning. A subfrequency field that disrupts visual spatial processing does not, in the same measure, disrupt acoustic spatial processing. At least, that's true for someone who has spent 20 years building their spatial reasoning predominantly around acoustic information. Do not know if it would be true for someone who had not. I opened my mouth slightly and listened to the chamber. The chamber told me, wide, low, 6 exits, hard floor of some composite material that reflects in the 1800 to 2000 Hz range, walls of something softer, probably the recalibration paneling Velharith had mentioned. The exits on the far wall were narrow relative to the chamber's width. The lateral exits were slightly wider. I walked to the right lateral exit, not because any map told me to, because the building's exterior profile, when I'd listened to it, had suggested the major volume concentration in the central section was offset slightly to the right of the building's centerline. If the labyrinth was roughly symmetric but not precisely symmetric, the path of least resistance, the fewest chambers to the terminal, might favor the right side. This was not a certainty, it was a working hypothesis. I walked, I should say, because it seems relevant. I am not fast. I do not have the physical profile of the Dorothy cadets I'd seen in the intake room. I am a 31-year-old acoustic engineer, of approximately average human height and build who exercises, because not exercising eventually causes structural problems, and not because I have any particular relationship with competitive performance. I walked through the labyrinth at a pace that felt natural for the corridors, which were neither cramped nor wide, enough room to move without touching the walls, tight enough that you were aware of the walls at all times. The second chamber was where the arrays stepped up. I felt it as a change in the pressure gradient. The sub-frequency emitters in this room were running at higher amplitude, and the spatial effect intensified. The room tried to tell my visual system that it was smaller than it was. Could feel my balance starting to do that mild loosening that comes with sustained infrasound exposure, proprioceptive drift that the Velshana cadet had described. I stopped in the middle of the chamber and listened. The chamber was oval. The resonance profile of an oval chamber is distinct. It focuses reflections in a characteristic way. I oriented to the reflections and found my position relative to the room's center, then located the exits by the acoustic shadows they cast in the reflection pattern. 3 exits in this chamber. 1 ahead, 1 to the right, 1 angled back left. I went right again. The 3rd chamber was where I started to understand the Labyrinth's logic. The Aerith built their structures around acoustic flow. The idea that space should direct occupants by what they could hear, not just what they could see. A well-designed Aerith corridor draws you forward by its sound signature the same way a well-designed visual space draws you forward by its sightlines. You stop noticing the guidance because it's so natural, you mistake it for your own preference. The Karathsol Labyrinth was not Aerith built, but it was designed by people who had at some point studied Aerith architecture. The chamber geometry was not arbitrary. The corridors were not randomly arranged. There was an acoustic logic to the layout, not fully realized, not as clean as Aerith work, but present. Each chamber had a resonance signature. The corridors that led toward the terminal, I was hypothesizing, but it was a working hypothesis, carried a slightly different acoustic profile than the corridors that led away from it or into dead-end loops. Specifically, the terminal side corridors had a slight acoustic brightening in the mid-frequency range. It was subtle. The designers may not have been aware they were doing it. It might have been an artifact of the terminal chamber's construction, leaking forward through the connecting architecture. But it was there. I walked toward bright chambers. 4 through 9 went faster than the first 3. The array calibration stepped up at each transition, the way Velharith had described, standard in the early chambers, elevated from 13 onward. In chambers 4 through 9, I was in the standard band, which meant the spatial disruption was significant but not severe. The gravitational variance was mild. A subtle sense of weight asymmetry, left side slightly lighter than right, that made the unconditioned body want to list. I corrected for it and kept moving. The floor geometry changed in chamber 6. It tilted, a slow shallow grade, maybe 6 degrees, that the visual system, already compromised by the arrays, could not accurately read. You felt it in your ankles before you saw it in the floor. I felt it in my ankles, understood the grade, and adjusted my gait. In chamber 7, recalibration panels did their job. The walls shifted, not dramatically, no sudden movement, no visible mechanics. The panels were apparently capable of very slow, very subtle repositioning, so that the chamber you entered did not have precisely the same geometry as the chamber you were standing in 30 seconds later. Disorientation by gradual revision. By the time you noticed the room had changed, it had already changed back, or changed again. I noticed in chamber 7 because I was listening, not looking, and the acoustic reflection pattern shifted. The room told me it was getting narrower at the back. I turned around. The back wall was closer than it had been when I entered. I acknowledged this information and continued forward. Chamber 8 was, the atmospheric pressure fluctuation became significant. A cycling, drop and recovery that most species would experience as mild to moderate discomfort, the kind of sensation you get in a descending aircraft, amplified. I'd spent significant time doing field work at depth in the Callaway Bay Channel survey equipment, which maintained non-standard pressure environments for inspection access. I recognized the sensation. I kept walking. Chamber 9 had all 3 systems running simultaneously at elevated parameters. The sub-frequency array, at what I estimated was 1.5 times the standard amplitude I'd entered with. The gravitational variance increased to a noticeable pull, and the atmospheric cycling in a faster period. I paused in the center of Chamber 9 for approximately 8 seconds, listened to the room's acoustic signature, identified the exit corridor I wanted, and walked to it. I did not feel good in Chamber 9. I want to be accurate about this. The compound effect of 3 simultaneous disorientation systems at elevated amplitude does things to the human body that are real and not nothing. The spatial softening of the visual field was pronounced enough that I had stopped trusting my eyes entirely by this point. My balance required active management. There was a low baseline nausea from the pressure cycling that I was handling by breathing in a particular way and ignoring. But feeling a thing and being stopped by it are different propositions. I had felt this category of sensation, not this specific combination, but this category, since I was a child. I walked through the corridor out of Chamber 9. Here is where the story changes. Between Chamber 9 and Chamber 10, I learned something about the labyrinth that I had not anticipated, and that, as far as I could tell, most cadets who came through this program did not know. The corridors connecting chambers in the labyrinth are not passive. They have their own array systems, lower amplitude than the chamber arrays, running continuously, calibrated to maintain a baseline disorientation between chambers, so that the effect doesn't reset when a cadet is in transit. Makes practical sense from the trial designer's perspective. You want sustained compound disorientation, chamber-specific bursts with recovery intervals between them. What the corridor arrays produce, in a building that is older than the array technology by about 600 years, is a sustained resonance interaction between the array output and the building's structural, acoustic properties. The Kareth Sol main building, which this facility is attached to, has designed structural elements that still function. The acoustic resonance logic that the Aerith built into the main building's foundations doesn't stop at the renovation junction. It extends, attenuated but present, into the labyrinth wing. The corridor between chambers 9 and 10 had an acoustic quality I had not encountered in the first 8 corridors. A particular resonance in the 100 to 200 Hz band, the low-mid frequency range, the range where human hearing is most sensitive in terms of localization. It sounded, to someone who'd spent 20 years listening to Aerith-influenced structures, like a direction. Not a sound, not a voice, just a direction, an orientation, a sense of where the acoustic center of the building was, and therefore where the terminal was, relative to where I was standing. I stopped walking and stood in the corridor for a moment. The building was giving me a map. Not a precise one. Not corridor by corridor. A bearing the same way a compass gives you a bearing. Not a route, just a direction. And from where I was standing, in the corridor between chambers 9 and 10, the bearing said, "The terminal is roughly that way," and the way I was walking was not quite that way. It was close. But if the bearing was right, I was slightly off-axis, and the off-axis path through the labyrinth, in a structure this size, probably added several chambers to the route. I took the bearing seriously, not because I was certain it was right, because it was data I had that most cadets in this program didn't. And in a 40-minute trial, the question isn't whether to use imperfect data. The question is whether imperfect data is better than no data. It was. I turned left at the Chamber 10 junction, away from the direction I'd been trending, and followed the bearing. Chambers 10 through 22 are the elevated section, and I'm not going to claim they were easy. The elevated arrays hit at the threshold I'd expected from Velharith's description, and then they exceeded what I'd expected at Chamber 15, where the gravitational variance climbed high enough that my left leg felt approximately 20% lighter than my right for the entire duration of my time in that chamber. It's a strange experience. Your body's motor programming for walking is calibrated to symmetrical weight distribution, and when that symmetry is disrupted, the uncalibrated body starts to compensate in ways that create a drift. You think you're walking straight, and you're not. You think you've corrected, and you've overcorrected. I had enough experience with asymmetric surface walking. Port fieldwork involves a lot of unstable surfaces, angled decks, pressure seal platforms, that I could manually override the drift, which means I was walking through Chamber 15, doing something that a neutral observer might have described as an extremely odd gait. Correct. Odd. Chamber 18 introduced a new element. The recalibration panels in this room didn't just shift the geometry, they shifted the exit positions. Not drastically, the exits were still in the general area where exits had been, but the panels repositioned them in a slow cycle. And the exits that had been clearly visible when I entered were not clearly visible when I needed them. because the visual spatial processing system was working at significantly reduced reliability by this point. I found the exits by their acoustic shadows, stood in the center of chamber 18, closed my eyes, which helped, not because the information was better that way, but because closing my eyes stopped my brain from trying to process the corrupted visual information and redirect that processing capacity and listen to the chamber's reflection pattern. 3 exits. One of them had a warmer reflection profile, a slight brightening in the mid-frequency range. The terminal side signal, which I'd been following since Chamber 3. I walked to the warm exit and went through it. Chamber 19 had a sub-frequency array running at nearly twice the amplitude of the entry section. Arrays. I know this because I could feel it in my back teeth, which is a real thing that happens at sufficient infrasound amplitude, and my back teeth had not been feeling it in the early chambers. My spatial processing was operating almost entirely on acoustic information at this point, and I was managing the balance issues through gate and wall touch. Periodic light contact with the corridor walls to maintain positional reference, a technique that port workers use in the equipment bays where visibility is poor. I was not, as far as I could tell, in distress. I was working. It felt like working. There's a difference between conditions that overwhelm you and conditions that require you to pay attention, and I had spent enough time in the latter to recognize which one this was. The bearing held. Chamber 22 was where the acoustic signal from the terminal became direct rather than structural. Not the building's Aerith-influenced resonance, but the terminal chamber itself. Its array systems running at whatever calibration the certification endpoint required, producing a distinctive acoustic signature that I could hear clearly from 2 chambers away. I was roughly on a straight line to the terminal. And the shortest path on a straight line in a building this size, if you started at the entry and the terminal was at the opposite end, was not through chambers 23 through 42, it was back. I want to explain the geometry here, because it matters. The Labyrinth's route is not a straight corridor from entry to terminal. If it were, there would be no disorientation, no navigation challenge. It is a network. 42 chambers, 118 corridors, designed so that the direct path from entry to terminal passes through most of the chambers in the network. A cadet who navigates well will choose efficient paths through that network. A cadet who navigates poorly will loop, backtrack, take dead ends. The network also includes the entry section chambers, which I had already traversed. And the entry gate, which I had come through, was on the north face of the building. And the terminal sensor, which I could now hear clearly at 2 chambers distance, was also, based on the acoustic bearing I'd been following, in the north section of the building. The Labyrinth was not a straight line from north to south, it folded. The route that the trial designers intended cadets to take ran south from the entry, through the central chamber mass, then curved east and north to the terminal. A long route, because the long route passed through the elevated arrays and the maximum number of chambers, maximizing the disorientation exposure. But I was at chamber 20, 40 meters from the terminal by direct path through the building structure, on the same side of the building as the entry. There was a corridor I had not taken in chamber 7, the one angled back left, that I'd passed over when I went right. I'd noted its acoustic profile at the time and moved on. I was thinking about it now. The back left corridor in chamber 7 would have taken me northeast, into the entry section of the building, toward the area where I'd started. Terminal chamber was in the northeast of the building. I stood in chamber 20 and ran the calculation. If I was right about the building geometry, and I had been right about it, consistently, for the past 20 chambers, then the terminal was approximately 6 chambers from my current position via the intended route, chambers 21 through 22, and then the long arc, east and north. It was approximately 4 chambers from my current position via a different route. Back through chambers 19, 18, 17, corridor I hadn't taken at the 17 junction, and north to the terminal. The direct route was shorter. Problem with the direct route was that I hadn't walked it, so I didn't know precisely what was in it. The problem with the intended route was that I had walked 8 of the last 12 chambers on a right bearing correction and right-bearing corrections. In a north-favoring building meant I was currently the farthest from the terminal I would be on the intended route. The intended route was about to get longer, not shorter, before it got shorter again. I made the decision in roughly 3 seconds. Thing about decisions made under compound disorientation is that you can't fully trust them, and you can't fully distrust them either. The sensory information feeding the decision is degraded, yes, but the decision-making framework, the logic structure, is not the same thing as the sensory input. You can have degraded input and sound logic. The question is whether the input is degraded enough to corrupt the logic, just degraded enough to make the logic feel uncertain. Those are different problems. I felt uncertain. The logic held. I went back. Retracing through the elevated array section was not comfortable. Chambers 20 through 17, backwards, with the elevated arrays still running, was the hardest part of the trial for me. Not because the disorientation was worse going back, because I was now navigating chambers I had already processed, and the array effects had shifted the apparent geometry, enough that my acoustic memory of those chambers was slightly misaligned with what I was experiencing re-entering them. I had to reorient in each chamber rather than relying on memory. In Chamber 18, I took the exit I hadn't taken the first time, not the warm signal exit I'd used going south, but the adjacent corridor that ran northeast toward the bearing. In Chamber 17, the gravitational variance had shifted since I passed through the first time. The heavier side had swapped, caught it in my second step, recalibrated, kept moving. In what I estimated was Chamber 14, the fourth chamber on the return path, the acoustic signal from the terminal was close enough that I wasn't navigating by bearing anymore. I was navigating by signal. The terminal chamber's array system had a distinctive cycling frequency in the 40 to 80 Hz range that I could hear as clearly as a motor running in a room one wall away. I walked toward it. 2 corridors, 1 chamber, 1 final corridor. The terminal chamber's door was unmarked. Standard sliding panel, same as every other chamber door in the facility. I pressed my hand to it and it opened. The terminal chamber was the largest space I had been in since entering the Labyrinth. The array systems were running at maximum. I could feel the sub-frequency field in my sternum, my teeth, the thin bones of my face. The spatial disruption in the visual field was severe. I couldn't tell with any accuracy how large the room was by looking at it. By sound, it was roughly cylindrical, roughly 50 meters across with a high ceiling. The major volume concentration in this section of the building that I'd registered from the outside 35 minutes ago. The terminal sensor was a column in the center of the room. I could hear its housing by the acoustic shadow it cast in the room's reflection pattern. I walked to it and pressed my marker chip to the sensor. The light on the chip changed from green to white. The Proctor AI's voice came through a speaker I hadn't seen. Cadet D4V0R1N. Certification trial complete. Time recorded, 9 minutes, 11 seconds. I put my hands in my pockets. The exit gate on the far side of the terminal chamber was already open. That was, I suspected, automatic on-chip confirmation. I walked through it into a short corridor that led out into a monitoring room with white walls and bright overhead lighting that my visual system appreciated enormously. The junior officer from the entry station was at a desk. He looked up when I came through the door, and then looked at his screen, and then looked up again. I found a bench along the wall and sat down. Vel Harith came into the monitoring room 14 minutes later. The next certified cadet, the big Dorothy from the front row, who came through the exit gate at 31 minutes and 22 seconds, which was apparently an excellent time, was sitting across the room from me, looking at his hands when Vel Harith arrived. The instructor stood in the doorway for a moment. He looked at the Dorothy cadet, then he looked at me. 9 minutes, he said. And 11 seconds, I said. He came into the room and stood in front of me. Not close, the standard conversational distance for a Veth Nalari, which is about 2 meters. He looked at me with those careful precise. His mandibles were very still. The record, he said. 18 minutes and 40 seconds. It has stood for 41 years. I didn't know the record, I said. No, he said. He seemed to consider this. How did you navigate? By sound. He was quiet for a moment. The disorientation arrays are designed to compound over the course of the route, he said. The visual spatial processing degradation is intentional. The calibration for human sensory parameters was confirmed from the Terran Integration Protocol dataset. I know, I said. The dataset indicates that human acoustic spatial processing is not meaningfully better than visual spatial processing under array conditions, he said. For humans, the two degrade in parallel. That's what the dataset says, I said. He looked at me. He was waiting for the rest. I grew up in an industrial port, I said. I've been navigating by sound since I was 8 years old. My visual spatial processing and my acoustic spatial processing don't run in parallel. One of them is significantly more developed than the other. Vel-Harith stood very still. The dataset was accurate, I said, for the sample population it used. He looked at me for a long time. The Dorothi cadet across the room was watching us with the focused attention of someone listening to something they expect to need to remember. Vel-Harith said, slowly, an acoustic engineer. Research specialty in institutional architecture, I said. Acoustic resonance profiling. He absorbed this. The Labyrinth, I said carefully, because I didn't want to overstep, has some Aerith acoustic logic in the connecting corridors. I think it's a residual effect from the main building's foundation. The corridors, running northeast of Chamber 17, have a signal, characteristic that's fairly legible if you know Aerith construction patterns. Vel-Harith's mandibles moved in a way I had not seen before. That characteristic, he said, after a moment, has been noted in the facility's maintenance records. It is classified as an ambient architectural artifact. It has not been classified as a navigational signal. No, I said. It probably wouldn't look like one if you weren't specifically listening for it. He stood there for another few seconds. Then he turned and walked to the monitoring desk, where a readout was showing the progress of the remaining cadets still inside the labyrinth. He studied it for a moment. Then he turned back to me. Cadet D4VR1N, he said. Yes. You came to this program on a clerical error. I did. You have not yet enrolled in the observational research track. I haven't had time to process the transfer paperwork. He looked at me for a moment longer. The Advanced Combat Labyrinth program, he said, also includes a practical survey component in which cadets complete spatial app assessments of the Academy's primary structures. It is a minor component. It has never been considered a specialty area. He paused. I am considering, he said, whether it should be. He walked back to the doorway, stopped. The transfer paperwork, he said, without turning around, would take 11 days to process. I know, I said. The next module of this program begins in 4 days. I looked at the white ceiling of the monitoring room. I thought about the labyrinth's acoustic geography, those northeast corridors, the Aerith signal I'd been reading, the terminal chamber's cycling frequency that I hadn't finished cataloging before I pressed the chip to the sensor. I thought about the fact that I had a recording kit in my bag and had not yet documented the labyrinth's acoustic profile in any systematic way. I'll stay in the program, I said. Vel-Harith nodded once to the doorframe and walked out. The Dorothi cadet across the room was still looking at me. After a moment, he said in careful conclave standard, "You navigated by sound." Yes. He thought about this. He had a careful, methodical quality to his thinking that showed on his face. The acoustic signal in the northeast corridors, he said. Could you teach someone else to read it? I looked at him. He had clear, dark eyes. The particular directness of the Dorothi, which is a species that does not do social indirection, and tends to mean exactly what they say. Probably, I said. He nodded. He looked at his hands. He looked back at me. My time was 31 minutes, he said. Good time, I said. Not 9 minutes, he said. No, I said. He was quiet for a moment then. I will be at the module start in 4 days. So will I said. I leaned my head back against the wall and closed my eyes and listened to the monitoring room. The ventilation, the equipment hum, the distant low-frequency rumble of the main building's foundations that had been designed 8 centuries ago to hold a kind of intelligence in its walls that most people walked through their whole lives without our hearing. It was still there. It had been there the whole time. That's the thing about a signal. It doesn't care whether you're listening. It just keeps going.